Hello grade 10s, we are now moving on to the midpoint formula. Now again, just like the previous one, I'm not too interested in the derivation of it. I'm more interested in this slide over here. So what you guys can get down for me is the heading, midpoint formula. And then this is the actual formula here. So the coordinates of M, the midpoint of the line joining points A and B, can be determined by this. Now, just like with the gradient formula that we went through, I want you guys to do it in another way. So this is capital M. Remember that the gradient is lowercase m, and this is going to be equal to x1 plus x2 over 2, y1 plus y2 over 2. Just like what we did with the gradient formula, okay? It's exactly the same formula, but I would rather you guys do it like this. It'll just make your lives a little bit easier. Okay, so going on to example 1, it says here, calculate the midpoint of the line joining the line segment joining P 1 minus 6 and Q 4 8. So M x1 plus x2 over 2, y1 plus y2 over 2. That is the formula, and it is a capital M. Now, this is our first point, so this would be x1, y1. This is our second point, so that's x2, y2. All I have to do is just substitute those values into this formula. So our x1 value is 1, plus our x2 value is 4. Our y1 value is minus 6. And our y2 value is 8. Okay guys, so just on your calculator, I'm just going to be doing this one first. Do not do them together, okay? They are not the same coordinate. We're going to look at the x first, work that one out, then look at the y, and then do that one next. Okay, so for this one over here, we've got, we've got 1 plus 4 over 2. And that will give us 5 over 2. Then we're going to do the y value next. So that's minus 6 plus 8 all over 2. And we get 1. So the midpoint's coordinate is 5 over 2, 1. Okay. Example 2, show that the line segments AB and CD bisect each other. Now guys, just to draw a picture of this and show you what it looks like, it doesn't make a difference how long a line segment is. Okay, so we can have a long one like that, and then we can have a relatively short one. What they mean by bisect like that is it means that the shorter one will cut the longer one in equal parts, and the longer one will cut the shorter one in equal parts. But you can see that this will be the same for both of them. In other words, it will be the same midpoint. Okay, so what I'm going to do is I'm going to find the midpoint for AB, and then I'll find the midpoint for CD. If they come out to be the same, therefore these things bisect each other. Okay, so let's find the midpoint of AB. Okay, and now with this one, I'm doing a subscript AB just to differentiate between our two midpoints, because you'll see that I'll get another midpoint CD here. Okay, so this is x1 plus x2 over 2, y1 plus y2 over 2. Okay, so this is our first x value, so that's minus 1 plus 3 over 2. Then our y1 is minus 2 plus 0 over 2. So we get the midpoint of AB is going to be, so for our x value, we're going to get minus 1 plus 3 over 2, and we get 1. And then over here, we will get minus 2 plus 0 over 2, and we get minus 1. Okay, so that's the midpoint of AB. Now I'm going to find the midpoint for CD. Let's see if I can get it in here. So the midpoint of CD will be equal to x1 plus x2 over 2 and y1 plus y2 over 2. Okay, so let me take that out. CD. Okay, so x1 is minus 1 plus x2 is 3 over 2. Y1 is 1 plus y2 is minus 3 all over 2. So we get the midpoint of CD is, we've got minus 1 plus 3 over 2, and we get 1. Then we get 1 plus minus 3 over 2, and we get minus 1. Now, have a look here, guys. The midpoint of AB is 1 minus 1, and the midpoint of CD is 1 minus 1. Okay, therefore they bisect. Therefore, AB and CD bisect, because their midpoints are equal. Okay, grade 10s, what you can do for me is exercise 11.3, numbers 1 and 3 for me, please. Thanks, guys, and enjoy.